Good morning, all of you. I'm Shravan Kumar from Delsoft Technologies, New Delhi. Delsoft Technology is a software solution provider in education, especially in engineering and research institutes. And we have different software solutions for various departments like electronics, electrical, computer science, IT, civil, and mechanical. So we keep trying faculties and research scholars about latest technologies related to various research areas. So in direction to that process, we are organizing this faculty development program, and today we are organizing this Target 3000 software webinar for circuit simulation and PCB design analysis. So as you can see in the screen, today's agenda, we will have an introduction of Target 3000 software, which is into circuit simulation and PCB design analysis. So we'll have a PPT presentation. After that, we'll design an analysis of an analog circuit using this software, which is having schematic, analog digital mixed mode analysis, PCB layout, 3D view, and Gerber creation. Then we'll have a digital circuit. Okay. So your mics we have muted just to avoid the voice interference. If you have any query, you can ask in the chat box. Okay. So this is Target 3001 software for PCB design and circuit simulation. And this is Target 3001 environment introduction. As you can see, first we will when we open this window, you will have this taskbar that is common in the many softwares like create new project, open existing file, save project, various cut, copy, paste. Various options are there. So this is for component database, opening the component database. Okay, this is the main tab just to open the component database, and this for simulation and wire creation. So we'll see in the software. So this is integrated PCB design simulation software. So basically, these kind of software are divided into 3 or 4 parts, mainly 3 parts. First is schematic. In schematic, we design our PCB or circuit. We'll be providing having a set of libraries of component in which we are having 36,000 plus components right now, and we keep updating this component database. So in schematic, we design the circuit. Okay, we just drag and drop the components, and using a wire, we connect those components and design our circuit. So this is first part of schematic. So after the creation, we have AD mixed mode simulation, analog digital mixed mode simulation. So after the schematic, we have to check whether our circuit is correct or not. So we go to the simulation and we do various analysis like transient, AC analysis, DC analysis by changing the parameters of timing, simulation timing, and parameters of components. We see the analysis of that circuit. So after this schematic and simulation, there is a part of layout. So we have designed the circuit, we have checked our circuit through simulation, and now we have to create that layout. So for creating that layout, this software has integrated various tools inside, that is auto placer, auto router. So when we design our circuit through this putting this component and creating the circuit, that is like sketching only. So if you want to create those circuit into the PCB, you have to be more optimized. So that optimization work will be performed through this auto placer and auto router. Okay. So when we created the layout, you can see the 3D view. You have the EMC analysis check, front panel layout, and it creates the manufacturing data also. Okay. So first part of schematic. You can see in the screenshot, some circuit is designed using this software. This is the software environment. So some circuit has been designed. So as I've told you, 36,000 plus component library is there, library browser is there, component management system. Okay. So schematic part is just to create the circuit, and after the schematic, we have mixed mode simulation, in which it has support for SPICE 3A5 and PSpice compatible. You must be knowing PSpice. Most of the faculties use PSpice, uh, PSpice or ORCAD. So it has the compatibility with that PSpice also. And it is mixed mode simulation, that is analog plus digital. Analysis is DC sweep, AC sweep and transient. Okay. It has an oscilloscope window. You can see in the screenshot. This is the oscilloscope window, in which when you run the simulation, you will see the graph into this oscilloscope only. Okay. So after the simulation, when you convert that circuit into the PCB, that auto placer will automatically work. You can see in the screenshot auto placer. There are various options available, like inside the PCB or outside the above the PCB, place SMDs first, on top or on bottom, order of placing. So these you have to configure. So when you start it, your schematic circuit would be converted into the PCB in the optimized space. Okay. So after the auto placer, there is an auto router. Auto placer is for optimizing the components. Now after the optimizing the component space, we have signals also. We have connected this those circuit. So those signals are not optimized. So we just to optimize those signals, we have auto router. Okay. So in auto router, there are three types of auto router given in this software. That is counter auto router, hybrid, and Electra. Counter and hybrid are inbuilt auto router in the software, and Electra is an external auto router. This is just to uh, it has been provided according to the complexity of the circuit. If you have a very complex circuit, you can use Electra auto router. Okay. So there are various parameter, drill hole diameters, algorithm you can define in the auto routing. Routing layers you can define, copper top or copper bottom. There are various parameters. I'll just show you in the software part. Just go into brief of this presentation. After the auto routing, there is a PCB layout. You can see in the screenshot, there is a layout figure is there. So when you auto route, it will create this layout, and it has also the interface with many softwares. It has up to 100 layers. You can create those layouts. Okay. You can check the DRC, real-time design rule check. Okay. After this, you can generate the Gerber files of this layout also. So after the layout, you can see the 3D view. So this 3D view of that circuit created, and it has some parameters like PCB, signals, layers, and package. Okay. Package has been provided. If there is a large circuit, you can check or uncheck this package, and one by one you can see where components are located. Okay. So there are four parameters given in 3D view. It is just to give you an overview how your circuit looks like after the creation of the circuit. So 3D view is there. After the 3D view, you can check EMC analysis, electromagnetic analysis of the circuit. It has also some parameters like radiation coupling, galvanic coupling, track length, inductive coupling, and coupling factors. So after the PCB layout, you can create the front panel layout also. For any circuit, you need the front panel. And there are some buttons, direct buttons are given there. You just have to set the parameters and you create the front panel layout. Okay. There are some benefits of this Target 3000 software, that it has a Gerber and production data. It has interface with some of these CNC machines or CAM machines companies. So if you create your circuit, it can give you the Gerber data of that CAM machines, and you can create directly those PCBs in the machines. And also it will create the GR file for manual production of the PCB. So it has both the option for manual production and for machine production. And it has one project file only. If you create any project, it has one extension .t3001. It will keep all the data of the file. It has a SQL component database, and licensing policy is very easy. Node lock is there. Okay, no activation codes, no hardware protection. License file is integrated with the CD only, and upgrades are online. Software update and component update are all online. You just have to connect with the internet, then you can get the updates of software and the components. So after this presentation, I'll go to the software. Here you can see this software environment. Okay. So this taskbar I've just shown you in the presentation, that create a new project, save, open, all these tabs are given there. Okay, this is for go to PCB view. If you are to convert schematic to PCB, there is a one button, go to PCB view. Okay, this is component, import component tab. So for creating any circuit, you just need component first. So if you click on this import component, you will get this window. So if you see here, when you click on any of the component, you can see the details of those components only. So here you can see there are two types of package, DIN package or IEEE package. So if you click on IEEE, it will give you the schematic view, package view and 3D view. Okay, and this is the details of this component, manufacturer, package, register and description of that component. Okay, and for importing that component, you just have to click on import component and it will connect with your mouse. You can place it anywhere in the workspace. And in attach mode, if you right click on that mouse, it will rotate. Okay, if you connect it with rotation, you can right click and rotate. Okay, this is for placing the component. You can select and delete. So here you can see the list of components available here: audio, capacitor, connector, socket. The components, as we know by their name, so these are listed here. Okay, like if you click on diode, it will give you all the diodes: bridge rectifier, diode, IR diode, laser diode, all the diodes it will give you. Okay, and so there is a search also. If you click on search, like if we type diode only, so it will give you all the diodes, which diode you want. So if you click on simple diode, it will give you a search result of that diodes. So this is just to search the component. If you know by their name or their specification, you can just search here. Okay, and also there are parametrical search available. This is for advanced search. If you want to search any component by their name, by their manufacturer specific, by their distributor, simulation models, 3D models, package type, package, like if you click on register, and go to the advanced search. In the register also, in the register you can search the register according to the resistance, according to their E series, power, resistance technology, tolerance, or any keywords, or their manufacturer, distributor, simulation models, package type, package. So this is for advanced search. If you have some specification and you want to search those specification, you can have those search in the parametric search, okay, according to one component. So, and there is an update option available. So in weekly or monthly time, the component database is available. Component database is updated in weekly or monthly time in the server of Germany that from this software belongs. So if you update it by connecting to the internet, you will get the update from here only. The components updated in their server will get updated with your systems. So component update is very easy. You can just have to click on update, and software update is also very easy. If you are using 1 month or 2 month older, it will give you the message that you are using an older version. So it will get automatically updated. So update is not an issue. So this is for component search. And apart from this import component, there are some categorized view of the components are given there. Like if you want to select sources only, so if you click on sources, you will get the sources only: constant, exponential, FM, pulse, PWL, sinus. All the sources will be available here. This for resistor, capacitor, inductor, diodes. So these are available in the categorized view. Okay. So I will just show you one small circuit just to show you the flow of the software, how we can work on it from this right from the schematic to the simulation layout, then 3D view and the manufacturing data, how we can create the manufacturing data and generate it. So we will have a small circuit of an rectifier. We just have to click on the sources and V sinus. We will have one sine wave. Okay, sine wave. Then we will have one diode, rectifier diode. One resistor. Okay. So we have placed these three components. So we can connect it directly and simulate it, but we want to create the PCB layout also. So as we know that sources in any circuit is external. So if you connect it and simulate, convert it into PCB, it will show you these two components only, because it is an external source, so it will not show in the layout. So just to have the place of this source, we will connect a 2-pin connector here. Like if you select it, place, we just search 1 cross 2. So we need an 1 cross 2 socket. So now we will connect this source through this connector. So when we convert it into layout, our circuit would be completed there. This socket would be available there in the layout. So we just have to connect this circuit through this place wire from here. And as you can see in all the components, there are cross wires. Cross wires are there. So we have to connect these components through this cross wire only. So when we take this mouse to this cross wire, that box is created. You just have to click on that box and connect this through the another socket. Okay, so this connection is complete. Now we have to take another from here and box, click here, then from here to this one, this source to this connector, then this connector to resistor. Okay, so we have to place one ground here. Now you can see our circuit is complete. We have source, diode, resistor, and this ground. Now in the schematic part, one more thing is remaining, the parameter setting. So as you can see, all the components having this cross. So if you click on this cross, you will get the symbol wizard. In you can see the value part. Okay, so if just set 400 ohm for this, click on OK. 400 ohm is set. For voltage, click on V sinus. Let's say it's 12 volt. If you want to change the frequencies of the voltage source, you can go to the simulation values, edit. You will have this frequency. Right now it is 1K. You can change it according to your requirement. Some other parameters also there. Okay. This diode is also has to be set on default values. So we just click on default. Okay. So now in schematic, as we have divided this working into the four parts. So first part is complete, the schematic part. So we have designed the circuit, we have set the parameters. Now we will analyze this circuit into the simulation. So for simulation, there is a tab, this one second last, start the simulation. When you click on this, you will get this simulation assistant. Okay. So by default it is transient analysis. It is if you click on this extended setting for transient analysis, you will get the parameters from here. If you want to change it, you can change the parameters: simulation timing, save timing, step at t is equal to 0, maximum step you can change. So in all this working, there are two main things that affect your result. One is the component parameters and one is simulation timing. So by varying these two factors, you can change your result in the simulation parameters or either this component parameter. So we just click on this. Apart from this transient analysis, we can have AC analysis and DC analysis also, and probes are also available. Probes, as you know, there you can set on these signals at any point. You can check the voltage and current parameters, okay, at any point. I'll just show you after this simulation. So we just start this simulation and we can see the oscilloscope window is there. Here this graph is created. So this is overlapping. So we have graph calculator. In this, if you click on show none and click on V plus, this is your input signal, 12-volt input signal. Okay, and this is Vk is your rectified output. Okay, this is a rectified output. This is your current value. So you can analyze one by one those signals, either one or compare input and output. So comparison of graph is there. Then apart from this, we have an editor for graph. Like if you want to create the logarithmic value, exponential value, log value, dB value, derivative, integral, minimum, maximum, RMS. So these kind of values can be created and their graphs can be seen in this oscilloscope window. Like if you want to see the RMS value of V plus signal, RMS value of V plus signal. So if you click on equal, it will give you 8.4847. So for this value, if you want to see the graph, click on OK, and you will get this graph. This is a graph for RMS value. So likewise, you can get the graphs of different values in the graph calculator. Okay, all the values. You can change the color and pen type also. These are available. So this is your second part completed, where there is a simulation. One more thing that probe, I just show you. For creating the probe, you have to select the select particular voltage and current. If you click on this, you can add voltage against ground, voltage against voltage, current on digital. So I just select voltage against ground. So you can see my mouse is converted into that voltage V sign. So this is like a voltmeter. If you click on this signal first, you can see signal V plus added. So this signal has been added, and this is your rectified output. So your rectified output is added, Vk and V plus. Or if you want to see only the output, you can remove it, click on OK and simulate. So you can see in the graph calculator, only your Vk signal is there, only output. If you want to see the output only. So this is proof function is there just to prove that value, voltage or current value. Likewise, you can add voltage or current, you can see from here. So schematic and simulation part is over. Now we will go to the layout part. In the layout, there is one single tab, go to PCB view. If you click on this, first you will get this PCB outline wizard. So you have to set the width and height of this PCB, or you can set this manually by just clicking on PCB, complete PCB outline. So after this, you will get auto placer window as I've shown you in the that presentation. So you have to change that inside the PCB or outside the PCB, SMDs on top or bottom, order of placing you can decide. So if you click on start, you can get your circuit in an optimized space placed over the PCB. So you can resize this PCB size by just dragging here. Okay. So this is your components placed over the PCB. This is your diode, resistor, and this is your socket connector. So if you have not connected this connector here for the voltage source, that voltage source would not have been placed here. So now our circuit is complete. and auto placer have worked. Now we have to optimize these signals. For that, I have told you we have to select auto router. So in actions, there is an auto router. So there are three types of auto router, as I've told you: Electra, hybrid, and counter. We can select any one because our circuit is small, so we can connect it through any of the router. So this is your hybrid router configuration. So in signals, there are various options available where you can define those parameters like route thick signal first, route short signal first, route only module, signal tracks. You can define the minimum track width, minimum track spacing. Default parameters are given there. If you have some your specification according to your requirement, you can change it. Vias are there, drill hole diameters, thickness of copper ring. Then algorithm you can define. You can avoid the disentangling between these signals, and you can increase or decrease the optimization level. If your circuit is very complex, you can increase the optimization levels, and you can remove between the signals and route again and again just to have the optimized signals. Okay, this for routing the layers. Okay, you just have to start it. So we can see our signal has been routed. Okay, now after the layout, we can see the 3D view of the circuit. So in view, there is a 3D view option. We can see our PCB. Okay, so any side you can move it. Our components are available here. This is diode. This is your connector. This is your resistor. So there is a package options available. If you have a larger circuit, you can just remove this components by unchecking this package, and you can click on one by one these components, that where are these placed. Like D1 is there, J1 your connector is there, your R1 your register is there. Okay, you can remove the signals. So this is just to give you the overview how your circuit will look like if you create this circuit into the real-time PCB. So we have seen from schematic to the simulation, layout, 3D view. Now if you want to make a real-time PCB through any of the means like CAM machines or through manual procedure, so we have to go through some options. Like if you click on file, input output format, then production, and engraving insulation channels. Okay, so if we click on this, we have these options. Production type, either is it double sided, copper top, copper bottom. So we just select the copper top only now. So there are some parameters for drill holes. Okay, drill fiducial holes for exact turning, and the very important is output format. As I've told you that it will generate the production data for various CAM machines. So these CAM machines are here only: HPGL, ISEL, Proma, CNC, Charlie Robot, Colin Bus, LPKF. These are some machines, CAM machines company, which support this target software. Okay, so if you want to create the file format for these companies for your circuit, you can just click on it and it will give you the milling data of your circuit. You can just send it those milling data to the company, and they will just give you the drill hole, all the drilling holing in the PCB through the CAM machines. So that is procedure for creating from for CAM machines. And there is an X Gerber for checking. You can see here X Gerber for checking. So this is for manual procedure. If you click on X Gerber, it will give you output format of GR file, GR format. So that GR file format, you have to take the printout of that GR file format, track layout, and you can create the manual PCB. Okay. So there are various parameters for drilling, drill immersion depth, drill tool, okay, speed of that tool, copper top parameters. Various parameters can be set or through the default parameters. That PCB outline, okay, then output. So we can set our new.gr file to the desktop, save it. Now we will have a PCB outline wizard with new window. Here we will open our that gr file from here in file, input output formats, data exchange documentation. Here read xgerber in excellent files. Okay, if you click on this, in read file you can open, you have new.gr file. Okay, you can open it. So this is your data for copper top. If you select the copper bottom, you will get the layer track layout also. So if you want to create the copper bottom, or let's say double sided, both the sides, we can save it. So this is your final layout. After the after opening that gr file, that track layout will come, and this is your final data that will give you uh, the printout and the manual procedure for having the PCB. So now we have created an analog circuit. Now I'll show you one digital circuit, how we can create it. And there is some small difference between analog and digital by giving the parameters. Okay. If we take full adder, This is a digital circuit. We have created one full adder. This is your XOR gate, 4081 ICs 4071. This is your sum and cout. So for giving the input in the digital circuit, we have to place one stimulator, that is stim, that we can get by writing the STIM into the component database. You will get this stim, that is stimulator, digital stimulus, where you can give the input through binaries, and in 0 and 1. Your simulation clock, that is continuous 0 and 1. So you have to select this stim. So if you click on stim in simulation values, and if you go to the edit and stimulus editor, in stimulus editor you edit it, you can see you can give the 0 and 1 through this text format. Like if we have given at 0 it is 0, at 1 it is 1, at 2 it is 1, and 3 it is 0, at 4 it is 1. So 0 to 4 we have given the input digital signal 0 1 1 0 1. So you can see in the this window that from 0 to 1 it is 0, and from 1 to 2 it is 1, so it is high. 2 to 3 it is 1, so it is continuously 1. Then at 3 to 4 it is 0, so it is 0. After 4 it is 1, so it is 1 signal. So we can give the binary input from this text. You save it, it will be saved in this text. Click on OK. Likewise, you can give the input for A, B, and C. Same thing. 0 to 4, 1, 1, 0, 1, 1. Okay. Then in C also. So 0, 1, 0, 1, 0. And this is about input, and these are your output. So these are some reference symbols which are available in this right side of this component tab. You click on reference, you will get these reference symbols like ground, signal input, signal output. So this signal output you have to take, import it, and you can place it here, and you can rename it to sum or cout, any name. Okay. So if you simulate it, you can see this digital, actually it is digital circuit, so both the signals are available in analog and digital. So you can analyze one by one. Like if you click on show none, you need to see DA, DB, DC in. These are three inputs, and it is your sum, and this is your carry. So we can analyze one by one. Then A, B, C is input, and sum and C out is your output. So we can compare according to their tables 0 and 1. Okay. And these are giving some warnings about ground, and some components are not completely imported. So this is just because this 4081 IC, 4071 ICs, these are not completely imported as it is not needed here, because we need, as you know, 407 IC is a big IC, and we have just imported of the 3-pin only. So it will, if you click on components and import rest of symbols, okay, so the rest of symbols will be available here. You have to place it. So these are warnings only, you need not be worried about this. So now it is completely imported. So as you can see, 4081 IC, it has 4 parts. Yeah, 1, 2, 3, 4, 5, 6, all the parts are there. And this is 14 and 7 pins, that is for power. It is there. You can provide 5 volt or to this power pin. And this is our 4071 IC having the 4 parts. So we need only this one, so we have imported this, and this is the power pins for this IC 407. Okay, so if your component is not completely imported, you can go to the components, import rest of symbols. Okay, and apart from this circuit, many of the demo projects are available here that will be installed in your system. When you install this software. Okay, so these are ready-made projects available here. If you click on any of these, like RLC, okay, on run, this will be your result. Okay, so these are some ready-made projects available here only. For PCBs also there are parameters given, like you click on dice PCB. This is some bigger circuit. Yeah. LEDs are there, and any 555 timer is there. So if you convert it into PCB, it will look like this. And if you see the 3D view, it will look like this. So this is a real PCB. Both the sides you can see. Okay. Here I've shown you that we can remove these packages and click one by one just to show where components are located. So that will help in this bigger circuit. Where components are located, we can see. So So now our presentation is over. If you have any query, you can ask me through your chat box. There is one question that is there any facility to design the CMOS and NMOS? Yeah, we can have the we can design the CMOS and NMOS circuits, but not up to the VLSI level, like not the source, gate, and drain. But their circuit we can create here and simulate it. There is one question that can we design op-amp circuit? Yes, sir, we can design an op-amp circuit here. We have some examples of op-amp circuit also. I'll just show you. This is LPF. Here you can. This is op-amp OTA, operation transconductor amplifier. There are some. I'll just show you in the component. All the components are available here. Op-amps. So you can create any circuit related to this op-amps. Okay. This is your op-amp circuit. Okay. Yes, sir. There is a question of microcontroller based design. So it has microcontroller based design. You can't simulate the microcontroller here, but you can create the PCBs of this microcontrollers. Microcontroller library is there. You can see in the component microcontroller library is there, but you can't simulate it. You can create their PCB, HTML, PIC, this microcontroller is there. Microcontroller, microprocessor, op-amps, optoelectronics, components are available. There is one question of interfacing between CMOS circuit with DSP. So interfacing is not available, sir. You can design the circuit and analyze it and create the PCBs. Can we design simulation profile of any sensors? Simulation profile can be created, sir. We have component wizard, component creation wizard. In that you can, if you have the that spice coding, you can create those components and by writing their simulation profiles, you can create it. Sir, how can you put code of microcontroller? So, so I just told you that microcontrollers can't be simulated in this, sir. You can create the PCB of that microcontroller. This is for PCB designing. A microcontroller is for PCB designing only. You can't simulate it here. Designing of FIR IR circuits. Yes, sir. FIR IR circuits are can be created here, sir. Demo video of design, sir. Demo videos are available. Some of the videos are available. We will share you through a mail. Yes, sir. By that low pass filter for if you have any circuits or LPF or any circuit, you can create it. Output file format support of the PCB design machine. Yes, sir. I've shown you in the that software part. Uh, this one. If you go to the input output format production and engraving installation channels, so these are output formats available here. HPGL, ISL Proma. These are CAM machines file format generated that can be generated here for different machines. This is for output format only. For 3D rendering images of component, so 3D images is available, sir. Uh, if you click on any component, I have shown in the component wizard. If you click on any component, you can see there is schematic view, 3D view, and package view. This is available. Some mini projects on PCB design. Yes, sir. We have a lot of experiments. We have already made some of the experiment, like according to some universities also. You can see here in this folder, we have created according to the UPTU University ECD lab. Their manuals are available one by one. If you if I just click on any of this experiment, we have set of manuals available, step by step manuals by having screenshots that we can provide you if you go through this software. Step by step manual is there, so they can use it, this manual projects for their mini project. Sir, for RTU university, sir, we have different university syllabus. So some of the experiments are common, sir. Some of the experiments are common. Some when they are different experiments, we can design it by having the components. Yes, sir. For UPTU, we have experiments, sir. UPTU. Yes, if you don't have any question, you can leave. For electrical students also, we have some projects. This software is beneficial for both the departments, electronics and electrical. There is one question of advantage of Target 3000 software over dip trace software. So dip trace, sir, is a PCB design only software, sir. Uh, and this is a complete PCB designing tool for schematic simulation, layout, and for manufacturing data. So it is a complete package for designing any circuit, right from the schematic simulation, 3D view, layout, all these things are included, and very user friendly. So for demo CD, you can download the software from the website, but it is feature restricted. It is a Discover version. It is having a limited features. So if you go through it, you will not be happy by using it. So we have this software as a full version. If you need it, we will give you the access of this software through TeamViewer or any. If you get the time, we will give you the access of this software for 1 hour or 45 minutes. You can use this software. We will be there to assist you if you want to use this software. There is one question that connector is compulsory to connect connector is not compulsory. If you want to simulate this circuit, connector is not compulsory. But if you want to generate this layout, you have to connect the connector, because you will not get the source in the layout if you connect directly. Sir, 1 hour is not sufficient, but we can give you more time, sir, for using this software. If you want to really use this software, you can download it, Discover version. But as I've told you that that is no feature restricted. Feature is very less there. It is useful for electrical students also, sir. It can create the circuit of electrical electronics both. There is one question that a number of users available for this software. So it comes as a package of 16 user package. So if you install it in your lab, you can create your full lab with 15 plus one user is available. 15 for a student and one is for faculty. That is concerned faculty for that lab. So it comes as a package of 16 user. Yes, sir. Electrical components are also included in this. You can see in the library there is. You can see electrical wiring, filters, fuse, okay, relays. All components are available, sir, for electrical also. Sir, for organizing the workshop in your college, we will mail you the details regarding this. If you need to search any component, just click on that. That motor is available, sir. Asynchronous. All these motors are there. For commercial details, sir, we will mail you if you need. The cost and their licensing configuration we will mail you. If some queries are left, you can note down this email ID and numbers. You can leave your queries to this email ID. We will answer it through mail. Okay. Thank you all for attending this webinar. If you have any query, you can note down this email ID and number. If you want some commercial details about this purchasing this software, proposal and technical details, we will send you through mail. Please give us an inquiry regarding the commercial details. We will send you on your mail for pricing and all the details. And please give your feedback about this webinar. We try to keep update and improve our this faculty development program sessions.